Anybody, anybody knows how to share my screen? I just cannot do it. Don't know how to do it. It's my first time to stream on YouTube. I just cannot find the button to share my screen. And the iPhone, don't know why. Okay, I tried. So there is on the upper right corner there is arrow, and click the link. Here, they will automatically find it. Okay, so hello everyone who have come to this class. Sorry for the delay, but you have to wait me for several minutes because I'm finding a way to share my screen. I got a software. Okay, so okay, we currently have 36 students here, so let's take some time waiting for more students to come, and we'll start maybe 5 minutes later. By the way, can everybody hear me? So yeah, so I am downloading a software called Open Broadcast software, which they told me that this software can help me to share my screen when doing a YouTube live. So we have to wait for a little bit a minute. Okay, so it may be your first time to see me in life. Perhaps I could be younger than you thought. That's because I am, how to say, I have just graduated about 1 year ago. I graduated on January of 2019, obtaining a doctor's degree in Queen's University of Belfast in the United Kingdom. And currently I'm 28 years old. I was, as you know, in United Kingdom it only took 1 year to obtain the master and 3 years to obtain the PhD. So I spent 4 years, almost 4 years there. And after that, I come back to China. And at that time, my fiance was in Henyang City. So that's the reason why I chose University of South China as my working place. And I'm very happy to be here. And I found that that was my first time to come to Henyang when I came to this university. But I'm really happy. How to say? I found it really happy to stay here. The food was delicious and the people were very welcome. And the most important thing is that now I live with my wife in a city. My wife, she majored in Spanish, but majored in Spanish when he was at an undergraduate, but now his job is totally unrelated with Spanish. So there are only 42 students. Can you call your classmates coming? I'm going to start the class when there are about maybe 80 or 90 students at least. Before that, we can have a casual talk. So, my wife, wait for me. So, my wife told me that when about 10 years ago, when she was about to choose the major for university, at that time he has already decided to learn a language, and others told her that Spanish was the second most used language in the world, and she took it and learned Spanish in Beijing Foreign Studies University. And later she found that all the countries which speak Spanish were very far away from China, mostly in South America. She do not want to go to a place so far away from home. So now he just works because how to say, you cannot find a job in Henyang City which related with Spanish. Do you think so? And she told me one of her friends now works in Cuba, and another friend of her now works in, I don't know, it's Bolivia or Ecuador. I don't know. I forgot it. And another works in. Anyway, it's a country in South America, so she didn't want to go there. So now, and she also cannot find a job in Henyang City related with Spanish. Because no one speaks Spanish here. So, anyone of you speaks Spanish? You can talk with my wife. She haven't speak Spanish for a long time. We have 46 students now. Which kind of language do you speak? I guess mostly Hindi, Urdu, or Hindustani maybe. Hindustani. Hindustani includes Hindi and Urdu, is that right? And also, I guess some speak Arabic, and of course English. And Chinese, is that right? How many? And I tell you a story that when I was studying in Belfast, I had a very good friend and a squash partner. We play squash about 2 or 3 times a week, and came from uh, he came from Karachi. And one day, I was having lunch with him, and there come an Indian mother come across, and they talked very happily, and I was surprised that how do you understand each other? And he told me that it's like it's just like Hindi and Urdu write differently, but it's very similar in oral when talked casually. Somehow, and I found that very interesting. Because in most cases, it's like how to say, you can in China, we write the same, but different places speak differently with different accents, but we write the same. And that's the first time for me to hear that they speak the same, but write differently. Okay, let me think about attendance. So my original idea was to use Rain Class as for recording attendance, and we live stream on YouTube. But the problem now is that we cannot even enter the Rain Class, not mentioning. So here says that Rain Class, there are too many visits of Rain Class, please come back later. So what I'm going to do, what's my plan now is that we broadcasting our class on YouTube, and from time to time I will check if Rain Class becomes available, and once it becomes available, we have attendance check on Rain Class, but we still have our class, we have our lecture on YouTube. And if the Rain Class didn't work until we end our class, you can type your student ID on the screen for the attendance. But they told me that after 5:30, the Rain Class will be much better because there will be not so many people after 5:30. Okay. Okay, the internet is quite slow. Sorry about that. Yeah, YouTube is, for me, as far as I'm concerned, YouTube is much better than Rain Class. But there are several problems. First, not everyone in China can get access to YouTube. And especially for those older teachers. And second, you may not believe it, but I can say that over maybe about half of Chinese do not know the existence of YouTube. I started to know YouTube like when I was 22, so I started. So that's the first problem. Second, because Ring class application, there is kind of cooperation between our university and the Ring class application. So they share data with each other, and the university can monitor how if a class is going where, how many students attend, and what's the performance of a teacher, kind of blah blah blah. Our teachers, including me, are complaining that the Ring class and other recommended applications from university always crash down, and it's not easy to use. But we are only a teacher, and we have no say on those policies. Okay, so just one thing before I start class, that when you try to type a comment or something, try to use English so that I can understand. some of you are typing. I don't know if it's a new language or it's some internet phrases that I do not know. But if you can use some more common phrases, which is much better for me to understand. So today, if everything goes well, today we are going to learn, finish the first chapter of introduction. Then we are going to learn something about how to name organic compound. I still don't know how to share my screen. Anyone got the advice of how to connect? Hey, how to say how to share my screen? It's a big problem. I just don't know how to share my screen. It's a big problem. And wait for another 5 minutes. So allow me 5 minutes. I try to setting the camera, setting the screen up. Okay. I'm downloading a software called OBS. I will try it first. Still have a hard time doing it. Uh, just for a moment. I kind of got it. encoder setup. I have to find my live stream key. Okay, for those newcomers, I'm still trying to figure out how to share my screen on YouTube Live. Taking me some time. I feel very sorry, but it takes some minutes. Anyway, it looks very complicated. I don't know if I can finish it today. How can I do this? So, because we do not have a lot of time, maybe still feel so bad. By the way, feel so bad. It's asking me a lot of things to verify. I think what I can do now. Have anyone, any of you have ever live streamed before? Google Hangout. I'm not a Hangout. Let's try. Is Google Hangout a new application or something? Okay, I'm trying Hangout. Okay, so okay. So for those who start listening, I sincerely apologize for this accident because I have no experience of live streaming, and I thought could be a button. I just click it and my screen can share to you. So, but when I opened the website, I found that there was not. Hmm, I'm trying to use the Hangout and ask students in the WeChat group. For the attendance issue, some of you have may come to here just now. So for the record of attendance, we are still using the Ring Class application because the university oversees us from the Ring Class application. But currently, the Ring Class is down due to too many visits, so we cannot get access to it. So that's why we are uh, we are having classes on the YouTube. So I was intended to give you a lecture about organic chemistry, but currently I cannot share my screen. So I'm trying to figuring out how to share my screen. Uh, I actually have the idea that so if you wait for me, wait. For the oh yeah, for the OBS Studio, I have downloaded it, but it asked me to have a like encoder stream key, and when I click on the stream key, it's like a whole bunch of menus, and it seems like I have to set up for a lot of things before I stream. Maybe cannot done uh I cannot finish it in an hour. I'm trying to so I'm trying to actually maybe I will use my iPad to live stream this class if I have no way to I will sort it out before next class. But for this class, maybe I have to use this one too. I actually have prepared some photos of mine for you to better understand me. But we leave it for our next class. So I have some trouble today. Okay, hello for those who still there. I apologize for my delay, but our this class has to be, but for our this lecture has to be like this. Oh, it's converse. Okay, no. Ah, it's bad. It's upside down. Ah, uh, I'm thinking. I'm trying to find out a way to deal with this situation. A hard time for me. Uh, try Google Hangout. Doesn't work. The reclass is still not open. So the thing I can do now is that you, you still I have shared our PowerPoint. Okay, so the thing we are going to do now is that for everyone still in this room, please check your WeChat and I have sent the I have sent the PDF version of our PowerPoint again on our YouTube, on our WeChat group, and you open the open the first chapter introduction, and you turn to page uh, turn to page 38. Yeah, we can only we start. We can only do like this. Our story is out before Wednesday, but today we can only have a lecture like this. I really apologize for this. So we turn to page 38. So last lecture we mentioned about what an atom is. So last lecture we were mostly reviewing what we have learned in our last semester for elementary or chemistry course. So for today, so last lecture we mentioned about what an atom is. The most important thing is to remember that there are four electrons, four outer shell electrons for carbon, and every atom in compound want to fill the electrons uh, of, to fill eight outer shell electrons to be the most stable one, except for hydrogen, which is 2. So we mentioned about ionic bond, which is formed when two atoms come close to each other, and one atom is very electronegative and another is electropositive. So electronegativity difference between them is very large. Then they will uh, they will form an ionic bond, but when their electronegativity is close, they will form a covalent bond. So in organic chemistry, most of the bond, maybe all of most of the bond is a covalent bond. So we will focus on what a covalent bond is. So we mentioned the common single bond last lecture, and The carbon-carbon single bond is formed by sharing one pair of electrons. So here in the page 37, 38, we have carbon-carbon double bond and even carbon-carbon triple bond. A typical example is carbon dioxide. Carbon dioxide. So carbon dioxide is here a carbon shared two electrons with the nearby oxygen to form a carbon-oxygen double bond. So this is what we learned for inorganic compound, which is carbon double bond. So, but if we turn to next page, we have so double bond and triple bond can also be formed between two carbons, like ethane, ethene and ethine. So you know how to pronounce it, right? So for the left one, C2H6 is called ethane, and C2H4 we call it ethene, and C2H2 we call it ethine or ethane. It refers to three different carbon bonds. Like they differ in the band length and the band energy. So you can guess which bond is the strongest. Like you can guess. So the strongest bond is of course the carbon-carbon triple bond, and also the triple bond is the smallest. It is natural because for triple bond you require much more energy to break it, so it's stronger and shorter. So in the next page 40, we got an example. The example asked you to draw the structure of C3H6 and having a one carbon-carbon double bond. And you can see the solution here. I give you, so now currently it's page 40. So we have no way but to finish today's class like this. I will try to sort it out on Wednesday. And I try to make it up on Wednesday. So on page 40, we got an example of a carbon-carbon double bond in C3H6. Give you 1 minute, you can have a look at the answer solutions, and you have to think about problem 1.14. You try to draw three different structures that have the same, that have the formula of C4H8 and have one carbon-carbon double bond. Okay, give you 1 minute to try to think about problem 1.14. So anyone got three different structures of C4H8? It is not that easy if it's your first time to think about those questions. So I show you answers here. Has anyone got it right? The question asks you to show three, and there are three and only three structures which can answer this question. So we have C4H8. So the double bond can be on the side, and double bond can be on the middle. And okay, sorry, got something wrong. So this one is not correct because this structure do not include double bond. It is a ring instead. So for C4H8, we have three possible structures. This one. So double bond in the middle and double bond in the side, and this one it have different carbon chain, and both these three are, we call those three isomers because they have the same formation by different bonding types. It is not that simple if it's your first time to come across those questions. So if you cannot fully understand, or you have problems drawing three different structures of C4H8, you keep it in mind. I will have more detailed explain in our next lecture because it's hard for me to explain without writing. Like it's quite hard. Okay, so coming to our next page 41, we have the valence. The valence of element is simply the number of bonds that an atom of element can form. I believe this concept you have learned in elementary chemistry, so I will not spend too much time here. So you have to, since you have to keep in mind that this carbon has a valence of 4, which means carbon can form 4 bonds. Nitrogen have a valence of 3, oxygen 2, fluorine 1. The number of valence equals the number of bonds they can form. So come for the next page, page 42, is example 1.10. Using dash for bonds, draw a structure of C3H4 that has proper valence of 1 for each hydrogen and 4 for each carbon. So here are three possibilities. Those questions are not that simple as try to reiterate again, like try to write out the structures of a certain formula, because how is it? Now we are coming across simple structures, but when the structure becomes large, it's very hard for you to write all structures. It's easy to forget one or two, but we start from simple one. So for C3H4, so how to think about the question? C3H4, so for 3 carbon, originally it should have 8 hydrogens, but still only 4. So 1 additional bond means 2 hydrogens. So there are 4 hydrogen less, which means the structure has 2 more bonds. So how do we have 2 more bonds? The first structure has a triple bond. Triple bond, there are 2 more bonds in a triple bond than a single bond. So the second structure is we have two double bonds. So 2 multiplied by 1 is 2. So the final one is we have a ring and we have a double bond, because a ring also detracts 2 hydrogens. So there are totally 3 possible for C3H4. So these 2 questions is what you haven't learned before, and if you find it no difficulty, congratulations, you have a very good, how to say, idea of combination and arrangement. But if you have difficulty trying to figure out all structures, don't worry, because that's our first 2 lectures, and we have a lot of exercises waiting for you in the future. So coming to our next page, so we have already learned that the same structure formula can produce different compounds. So we call it isomerism. So the molecular formula for a substance tells us the number of different atoms present, but a structural formula tells us how those atoms are arranged. For example, if we say H2O, it's a molecular formula. If we write H-OH, it's become a structural formula. The structural formula tells us which which two atoms are bonding each other, and it gives us more accurate information. Let me see if the ring class is open. No, still the ring class is still not working. Okay, so ring class is still not working, so we continue our lecture. So come to next page, page 44. It is sometimes possible to arrange the same atom in more than one ways, which we have already experienced, and we call it isomers. Isomers have the same molecular formula, but different structural formula. So there gives us two examples, the example of ethanol and methoxomethane. They have same structure, same molecular formula, but different structural formulas. So here comes problem 1.15. Can you try to draw 3 different isomers of C3H8O? It's not easy. I give you several minutes to think about it. It's page 45. Take some time to try to get a blank paper and a pen and a blank paper to think about it. It's not as easy as you think. 3 possible different isomers of C3H8O. Okay, has anyone got it? I show you the answer here. Try to figure out if you got everything right. We have 3 possible structures here. First, so C3H8 there could be there. So because 1 carbon corresponding to 2 hydrogen, 2 carbon to 6 and 3 to 8. So there could be no more double bonds or triple bonds here. Every bond is single. So the first possibility is to put the hydroxyl on the side. See, it is structure first possible structure. Second is to put hydroxyl in the second carbon. So this is the second possibility. And the third one, final one, is not alcohol, but we try to put the oxygen in between 2 carbons, which produce the third structure. So the first structure, hydroxyl on the side. Second structure, hydroxyl on the middle. And the third is ether, which oxygen between 2 carbons. So you can see if you got 3 structures right. We will review these questions in our next class. So here we go. Just proceed. So next page 46 is a writing structure formula. So for if you have carried out previous two problems by yourself, you may already notice that it's very troublesome for us to write all kind of bonds and hydrogens. So here we have a simpler way to write structures. So if you look at page 47, we have abbreviated structure formulas, which we have write CH3, CH2OH. So we do not have to write CHHH. We just write CH3 and that's enough. And we don't have to write bond. We just naturally link together. So this is page 47. It's abbreviated structure formulas. And from this point on, I will write the abbreviated structure formulas in the rest of our lectures. So here there are more examples in the following page. And in page 49, there are examples of how you turn a structure, abbreviated one, into a fully expanded one. Give you 1 minute, 1 to 2 minutes to have a look at this. So from those question solutions, you can notice that the abbreviated structures formulas really saved us a lot of time. And is there any simpler forms? And the answer is there is. So if you turn to next page, page 50, the abbreviated structure formulas can be even simpler. We call it line structures because it just use lines to represent the carbon framework. And the next page is page 51. It's a detailed explanation of how an abbreviated structure formula is. So, like here in the abbreviated structure, each line corresponds to a bond. If it is a double bond, you use the double line, and each node of the line corresponds to a carbon, and we ignore our hydrogens because because hydrogens can be deduced from the structure we have already known. It looks very abstract if you haven't came across this notation before. So I ask you to. It's really important. I ask you to have a paper, blank paper and pen, to work on problem 1.23 and 1.24 based on the ideas we have learned on page 50, 51, and the examples of 52. I give you 3 minutes. It's an important question. So for everybody who is listening now, try to work on it. So you have a quick review of page 50 to 51 and have a look at the examples from page 52 and try to work on the problem 1.23 and 24 by yourself. And if you work on this, if you solve these two problems comfortably by yourself, you have no problem of converting structures between those two. 3 minutes for this because it's really important. Do you feel comfortable when solving these questions? Okay, here show you the answers. Answers. Everyone got it right. So the problem 1.23 could be simpler. So it's CH from left to right. It's CH3, CH, and diverge two ways, and each way is a CH2, CH3. And for the second one, it's much harder. It's so you use a double line to simplify to represent double bond, and on the left line, on the left point, the carbon link to another two carbons. So we have two lines extending out, and on the other side we have CH and CH2, CH3, CH3. So we have one line extending out and further extended into two sections. So those are how to say, we will not have those kind of problems in the future because those conversion structures will be integrated into our daily daily teaching of organic chemistry and the usage of our organic symbols. It should be an in our next lecture, in our following lectures, you should be feeling more and more comfortable about writing those kind of structures uh, because you use it every day in organic chemistry. Okay, so this is problem 123 and 24. So we continue to next page of page 53. Page 53 and the following pages give us the idea of how about how to say the how showing us the quantum chemical viewpoint of how a bond is formed. So you may have heard, you have learned in your elementary chemistry course that orbitals can a carbon. So for uh, there are four orbitals for carbon in a second shell, which is 2s, 2px, 2py, and 2pz. So 2s is a sphere shape, and 2p is a dumbbell shape. So there are two types of carbons when those orbitals are bonding each other. The first type is a sigma bond when two orbitals overlap each other head by head. You do for this quantum chemical part, you do not really have to understand everything. So I'm trying to use my simplest word to explain it. So for the sigma bond, thing you have to know that sigma bond is strong and it's formed by the overlap head to head. And the next page comes for the pi bond. Pi bond you have also learned last semester is the overlap side by side, which is weaker than sigma bond. So if you do not want to memorize all those kind of weird shapes, you don't have to. But what you have to remember. You can hear me, right? Everybody can hear me, right? So what you have to remember is that sigma bond is a head-to-head overlap and is strong. A pi bond is side-to-side overlap and is weak. This is your take-home message for this part. And following this, we have a classification of our organic molecules. We can classify it by its shape. We can have a chain compound and a cyclic compound. And for those cyclic compound, we can have carbon cyclic compounds and heterocyclic compounds. Also, we can classify it according to functional group. And for our first 4 chapters, we focus on the carbon things, and after that, we're going to have learn also alcohols, halides, and ethers, acid, and we will introduce the functional groups. And page 59 is the summary of main functional groups available in organic chemistry. You can have a quick view of it. We have alkene, alkane, arene, alcohol, ether, aldehyde, and ketone. And we also have acid and so on. And the page 60 is the homework. And for the homework, please listen carefully. For the homework, everybody see the homework. For the homework, I ask everybody to prepare. Do you have a set Kindle? Anyway, try to prepare a book. Try to prepare a book like this, a notebook like this. It do not have to be very thick. It's. I think this one is. It's very enough. A notebook like this. I will give you questions every lecture. I will give you homework problems to work with at the end of each chapter. In this semester, for this course, we learn 10. We learn total at a total of 10 chapters. And I'll give you questions at the end of each chapter. And you write those questions in the notebook you prepared. And I strongly advise you to write all homework at one book because that's easier for me to check. You do not have to write on. I strongly do not advise you to write it on a blank paper because in that case you have at least 10 papers to hand. It's easy for you to lose it. So I advise you to prepare a notebook, and you can have all your semester's work in the same notebook, and I will check it. It's easier for me to check. By the way, I just forgot. So when I say we have 10 chapters, I use a symbol like this. it's in Chinese way to say 10. I don't. It's when Chinese say 10, sometimes they will use they use they will cross their figure like this. So the homework first chapter is actually quite easy, and I hope you can finish it in very quickly. But I but I have to say that I have to told you that the homework in the following chapters will be harder and harder. So you have to take it seriously. But first time is easy, but you have to take it seriously, especially for the following chapters. And I will explain. We don't have answer to this question. We don't have an answer sheet, but I will explain it every questions, every homework problems I leave in the coming lectures. So don't worry. So you try your best to work on it. If you uh, have difficulties, you just leave it, and I will explain it. So the thing, the way I recommend for learning organic chemistry or learning all kinds of or studying all kinds of subject is that so first listen to the teacher carefully, try to figure out the concepts by the explanation. But a lot of concepts can not be memorized only by repeating the explanations. You have to work on it. You have to use those concepts in solving problems, which will consolidate your memory and also teach you how these rules are used. So that's why I focus on exercise a lot. So I also ask you to work to take those exercises serious, and I will explain in the following lectures. And I have to tell you one thing before I close today's lecture that last semester, which means your upperclassmen and upperclass girls, the class of 2018, I had 125 students in the organic chemistry class, and only 55 of them passed in the exam, in the first exam. So which means organic chemistry could be very difficult. You have to take it seriously. I also feel very sad because maybe my teaching method was bad or people don't like listening to me. But I really want you can learn something from this course because organic chemistry is like a fundamental course in the way of becoming a doctor. You will uh, you will have come across a lot of chemicals in a hospital. You have to all kinds of medicines, uh, all kind of liquid which contains a lot of chemistry, especially organic chemistry. I really hope in the future you can still benefit from some knowledge of my course, and I will be very, very happy about that. Okay, so I think that's for today. It has enough for today, and I have to close this lecture. Do not forget to work on the problems. That's very important, and I will take it very serious. And for those who do not, I know from my experience, some of you have already learned some organic chemistry in high school, and some of you haven't. So for you, for those who have learned, you may feel it's very simple. But for those who haven't learned organic chemistry in high school, I strongly recommend you to finish those homework before Wednesday, so that you can have a better understanding of what I am going to teach on Wednesday. And also, if you find it difficult solving those problems, first have a review of the slides I give you for the introduction part. The slides I give are written in very detail, so you do not need to buy a book if you don't want. So, uh, but read carefully for the slide, and I think you can find answers for those questions and work it independently, especially for those who haven't learned organic chemistry in high school. Because last semester, about 40 students wrote the 20, and with with many blanks in the paper. And I asked some of you upperclassmen, upper class girls, why. They told me that some students say have learned organic chemistry and they feel it's easy, but many of them haven't learned anything about organic chemistry in high school and found it very difficult. So for those students, I highly recommend you to take it seriously from chapter 1, and you will, and I hope get a good score in the final exam. So I will before the end of the class, I check the ring class again. Okay, so ring class is open. So we will check our attendance in ring class. Just wait for a minute. Uh, just wait for a minute. Ring class come back to normal. So we check our attendance there. So there are currently 36 students have signed in, and I will leave this class. So I will close the ring class in 10 minutes. So ask your friends to sign in 10 minutes. And I'm closing the YouTube live now, and if we have more problems, we discuss in WeChat. So goodbye for today.